International Leptospirosis Society, Indonesia ranked third as a country with a high leptospirosis mortality rate. Isn't it scary?
It's scary than scary, especially with the fact that leptospira disease is caused by leptospira bacteria contaminate the soil and the water and gets into our injured skin and flowing deeper to our whole body.
Oh no!
So it's our time to make a move and solve this problem. Look at this. I just read about antibiotic for leptospirosis, but it still says that they still need to improve their understanding about the quality of the treatment regarding leptospirosis. So until now, affordable and effective antibiotic has not been found yet.
But wait, I've ever heard about a particle which are very small. It's mainly used in pharmaceutical fields, since it has higher absorption and also solubility rate than the usual particles. But I really forgot the names. Oh my god.
Isn't it nanoparticle?
Exactly, it's nanoparticle, yeah. But it seems like it's impossible to make that kind of things.
No, it's not. Here, take a look. In Ambarawa market, every day produce fruit waste as much as 8,013 kg, with the presentation of the most orange waste 64.67%.
By the way, what will we do with that orange waste?
Good questions. We will use this orange peel waste as the bioreactor in the making of nanoparticles, which contain various antioxidant substances such as phenols and flavonoids to make a perfect antibiotic.
Assalamualaikum warahmatullahi wabarakatuh. We're delighted to have you join us in this exciting research project with the title of The Effectiveness of Antibacterial Silver Nanoparticles
with bioreactor of Ambarawa fruit waste against Leptospira sp.
First of all, clean the orange peel waste with water to remove the pesticide residues and dirt on orange peels.
However, because the water in the plant can cause mold and bacteria, it is necessary to try it in the shade to maintain the stability of the compounds to be extracted.
Next, dried orange peel waste is grinded to become a powder using a blender for about 20 minutes to expand the surface area so that the effectiveness during extraction will also increase.
Let's move on to the extraction process. We chose the subluxation method because it avoids direct exposure of the solvent as well as the orange peel powder to heat like reflux.
This method aims to separate the antioxidant content contained in orange peel powder by repeated filtration using 96% of alcohol. We are now in the main part of the process, which is silver nanoparticle synthesis.
The orange peel extract that has been obtained from the subluxation process is measured according to the predetermined variables, namely 1, 2, 3, 4, and 5 milliliters, and then each variable is mixed with 12 milliliters of PVA 1.5%.
The use of PVA acts as a cupping agent, which maintains the stability of nanoparticles by reducing the clumping of nanoparticles. So, the antibacterial produce nanoparticle with a more similar size.
Then, double the extraction variable so that each variation is added with 15 ml of silver nitrate with a concentration of 0.5 millimole, and the other 5 variables are added with 20 milliliters of 1 millimole silver nitrate using a burette while stirring using a magnetic stirrer for 2 hours. Do not use the strong RPM to mix because it will affect the homogeneity of the silver nitrate. The formation of nanoparticles can be seen from the change in color of the solution, which become brownish after standing for several hours.
We move on to the characterization step with a UV spectrophotometer to determine the absorbance value of the silver nanoparticle solution. A large absorbance value represents a lot of nanoparticles formed and vice versa. The device is set from the beginning with a wavelength of 450 nanometer because at this wavelength, silver particles will be reduced perfectly. Starting with this data, which represents silver nanoparticles with a concentration of silver nitrate 0.5 millimole, it shows that bioreactors with volumes of 1 milliliters and 2 milliliters produce stable nanoparticles. Whereas in silver nanoparticles with bioreactor 3 milliliters, 4 milliliters, and 5 milliliters, absorbance value numbers decrease on day 3. This event is called agglomeration, or a phenomenon of reuniting particles arranged, the size becomes larger. It can be concluded that the best two variation of silver nanoparticle solution from the first silver nitrate 0.5 millimole concentration is 2 milliliters bioreactor because it has a good stability and absorbance number are quite high. Then is the variation with 5 milliliters bioreactor because the difference in agglomeration value is small and has the highest absorbance value. This one with the concentration of silver nitrate 1 millimole. Looks more stable, right? But except for the 4 milliliters variations which experience agglomeration. It can be decided that two best variation of the silver nitrate 1 millimole concentration are 2 milliliters and 5 milliliters because of the stability factor and the absorbance value.
Next is we need to make more proof that the nanoparticles are really formed by measuring the diameter of each particle using particle size analyzer as well as knowing how homogeneous Ag and PS are formed, or the polydispersity index. PI's rule is if the number nearer to 0 is more homogeneous than over 0.3 with maximum PI value is 0.7. It is also affected by the speed of the stirrer. If it is too high, it will enlarge the particle size, and if it's too low, the solution is not homogeneous. So first of all, you must know the identity of the sample, namely. We clearly see the sample A graph has a diameter of 114.7 nanometer with the PA 0.189, and sample B has a diameter of 116.2 nanometer with PI is lesser than sample A, it's 0.161. In conclusion, increasing the concentration, increasing the number of particles, increasing the speed of moving motion of particles, which result in smaller diameter particles because they tend to continue to move so as to reduce the possibility of agglomeration. Likewise, with sample C and D, the diameter of sample C is 81.5 nanometer, smaller than sample D, which is 95.5 nanometer. But both have reverse BI of the sample A and B, which the sample D with 0.5 millimole silver nitrate has greater BI. That means sample D's polydispersity index is being inhibited.
Now, it's time for the antibacterial activity test. We use the alternative bacteria such as E. coli and E. cloaca instead. The use of the two bacteria is based on the characteristic of the two bacteria which have similarities with Leptospira. The three microorganisms are categorized as gram-negative bacteria, parasite bacteria, and in terms of respiration, the three bacteria are classified as facultative aerobic bacteria.
In this study, the antibacterial test was carried out by the disk diffusion method. In the first step, the test bacteria, namely E. coli and E. cloaca, were grown in NA media on a plastic disc, then placed a paper disc that had previously been wet by a concentration of nanoparticle solution. In addition, in each plastic disc, there was a paper disc that had been wet by 1% DMSO solution as a negative control, and also 0.1% chloramphenicol as a positive control. This is the result. From the data shows that all the results take numbers below 5 millimeters, which indicates that the ability of sulfur nanoparticle antibiotics with bioreductors of Ambertawa method food waste is relatively weak.
The mechanism of antibacterial activity of sulfur nanoparticles involves the dissolution of sulfur nanoparticles by releasing antimicrobial sulfur ions, which can directly interact with proteins that form thiol groups on the bacterial cell wall and interfere with their proper function. It is also known that AG and PS can increase the trans and GS ratio of unsaturated membrane fatty acid, which affect changes in membrane fluidity and lipid bilayer compositions. This causes changes in membrane structure that can prevent membrane function, resulting in increased permeability and loss of membrane integrity, making it easier for AG and PS to directly enter the cell and interact with vital biomolecules.
After that, AG and PS attack enzyme, and especially respiration enzyme, and membrane-bound proteins through interaction with disulfide bonds and blocking of active site. This results in generating cellular oxidative stress in microbes as well as reactive oxygen species or ROS, and to oxidize fatty acid double bonds in the membrane, which allow the formation of other free radicals and ends up damaging the cell membrane.
First, the synthesis of sulfur nanoparticles with the most stable result was obtained from the AgNO3 concentration variation of 1 millimole.
Second, the synthesis of sulfur nanoparticles with absorbent values that tend to rise and stabilize up to 4 times 24 hours was obtained from the variation of the volume of bioreductor action from fluid waste as much as 2 milliliters.
Sulfur nanoparticles have antibacterial activity against gram-negative bacteria, substitute for Leptospira sp, which has an antibacterial activity indicated by a clear zone diameter